So this time we have a function, the cosine of x minus 1 over x squared when x isn't 0, and the function is minus a half when it's 0. It says the function f defined above has derivatives of all order. Let g be the function defined by 1 plus the area under the curve for this function. We're asked to write the first three non-zero terms in the general term of the Taylor series for the cosine about x equals 0. Use the series to write the first three non-zero terms in the general term of f. Okay, so we need the cosine, the first three non-zero terms. So we should be comfortable with this. 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial plus dot dot dot. So this would be minus 1 to the n, x to the 2n, all over 2n factorial is our general term. Now for f of x, I actually did a lot more work than I needed to for this one, but that's okay. I guess I'm not going to worry about that for you guys. So f of x is going to be minus a half when x is 0, and then it's going to be the cosine of x term minus 1 divided by x squared. So, okay, I'm going to cross this out for a second. So let's take, so f of x is the cosine of x minus 1 all over x squared. So this is the way I figured it out on my own. 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial. Now we're going to subtract 1, and then we're going to divide it by x squared. So these ones drop out, and I have this over this, so I have minus x squared over 2 over x squared plus x to the fourth over 4 factorial all over x squared. The next one would be minus x to the 6 over 6 factorial all over x squared. And if we simplify this, it boils down to minus a half plus x squared over 24 minus x to the fourth over 720. So there's our first three terms. Use the Taylor series for f about x equals 0 to determine whether f has a relative max, relative min, or neither. Lights coming back on. You know what, I'm just going to stay here because I think you can see good enough. Alright, so when we have a max or a min, what do we know? We know that happens when f prime of x is equal to 0. So what we need to do is to take our problem and find f prime of x. So f prime of x is going to, we're going to differentiate this guy right here. We'd get something like 1 over 12x. And then we would get minus 4x cubed over 720, and then dot 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 dot. So we want to know what's going on at 0. So f prime of 0 is going to be 0. So we would say, yes, we have a max or min. And now we have to figure out which one we have. So we can use a theorem from chapter 4 where we end up taking the second derivative. When I take the second derivative, I notice the first term I get is 1/12. And then the next term would be something like minus 12x squared over 720. And when I evaluate at 0, this term is going to drop out. So what do I know? I know that f double prime is always positive. So there's a theorem that says when you know your first derivative is 0 and your second derivative is always positive, then you know you have a min. So just think of a graph that looks like this. Concave up, and that's going to happen when you have a min. So that's how you would do problem B. C, write the fifth degree Taylor polynomial for g about x equals 0. So g of x is 1 plus the integral f of t dt. So we're going to take 1 plus the integral from 0 to x, and the 5th degree term, so that means we have to integrate minus a half plus x squared over 24 minus x to the 4th over 720 with respect to x. So we're going to get 1 minus 1/2 x plus x cubed over 24 times 3 minus x to the 5th over 720 times 5. And I could rewrite this as 1 minus a half x plus x cubed over 3 times 4 factorial and minus x to the 5th over 5 times 6 factorial is how this is simplified. Yes, you could work this out, these numbers, if you would rather use those instead of the factorials. And finally, for D, the Taylor series evaluated at 1 is an alternating series with individual terms that decrease in absolute value. Use the 3rd degree Taylor polynomial for G to estimate the value of G sub 1. Explain why this estimate differs from the actual value of G sub 1 by less than a half. Okay. So G sub x is, we're going to take the first few terms like it says, 1 minus 1/2 x plus x cubed over 3 times 4 factorial. Then we're going to find G sub 1, so this would be 1 minus a half plus 1 over 72. So getting common denominators of 72 over 72, or 72, I would find that G sub 1 is 37 over 72. So now we need to show that the error is less than 1 over 6 factorial. So what we have to do is take we basically want to go back here and take this term right here and take the absolute value, because that gives us everything that we need for this problem. It's going to give us our f of 5 over 6 factorial. So 1 over 5th is our f of 5, and we have, or I'm sorry, it's going to give us all the terms that we need. So we know that we're talking about 1, so this is going to be 1 to the 5th power over everything that's left from that term is going to be less than 1 over 6 factorial. And recall that when we're looking at this, this is going to be in the form of our 5th derivative, x to the 5th, all over 5 factorial. So that means everything, this is going to be equal to what we have here, x to the 5th, and then there is a minus sign if you